guys, today we're going to be working on solving some more equations. Today we're looking at one-step equations with addition and subtraction. So the equations we saw yesterday were one-step equations. And it's also important to know that one-step equations can also, yesterday we were doing it in our head, but today we're going to have to be showing our work, can also be solved using inverse operations. So we have one-step equations, so that's kind of a new term to you. We have inverse operations. Inverse operations undo each other. So they're kind of like the opposites. So for example, addition is undone by subtraction and vice versa. They are inverse operations. And multiplication is undone by what? You got it. Division. And vice versa. So multiplication undoes division, division undoes multiplication. Addition undoes subtraction, subtraction undoes addition. So they undo each other. They are inverse operations. So to solve, steps to solve a one-step equation using inverse operations. So here's the important part, guys. Number 1, locate the variable. Where is that x? Where is that y? Where is that G? Whatever the letter happens to be, right? Number 2, determine, so we got to figure out the operation tied to the variable. So is something being added to it, subtracted from it? Is it being subtracted from something? Is it being multiplied by something? Is it being divided by something? Then we have to use inverse operations on both sides of the equal sign. Whoa, I'm losing my the. That's what happens when I don't look at the paper when I'm writing. Use inverse operations on both sides of the equal sign to solve. Whatever you do to one side, you have to do to the other side. You can't totally just change things up without keeping it equal. And then finally, just like yesterday when we were checking solutions, you should check your solution. Okay? So it's important to remember that we have to do the same thing to each side, and that is called the addition property of equality when we're adding to both sides. So when you add the same number to both sides, the two sides remain equal. So when we're solving equations with addition, that means something is being subtracted from x. So x minus 3 equals 4. This means we have to undo it. So we locate the variable. What's tied to it? Subtraction. So we have to use the inverse operation of subtraction, which is addition, and we have to add to both sides. See how I draw a great big line there? I added 3 to this side, and I'm going to write it right under what I'm getting rid of. I'm going to add it right under where I'm adding to. So 3 minus 3 is of course 0, so I'm left with just x, which is what I want. 4 plus 3 is 7, right? And then you would put it back in. Here's your answer, and here's your checking. 7 minus 3 equals 4. 4 equals 4. So yes, that worked. Number 2. 15 equals k minus 8. So locate the variable. There's our k. Something is being subtracted from it. So we have to use the inverse of subtraction, which is addition. We have to add whatever that is. We're going to add 8 because we want that to be 0. Because we want k to be by itself. Lonely, I'm so lonely. K. So then we would plug it back in. There's our answer. 15 equals 23 minus 8. 15 equals 15. Checks out. Okay, so that is what addition looks like. Let's try some subtraction, and then I'll give you a few to try on your own. So remember, the subtraction property of equality. Subtraction property of equality is, of course, when you subtract the same number from both sides of the equation, the two sides remain equal. So we could have said the addition and subtraction properties of equality are when you add or subtract the same number from both sides of the equation, the two sides remain equal. But it helps us to remember that we have to do whatever we do to one side, we got to do to the other. Alright, so examples for these would be x plus 5 equals 16. Find the variable. It's being added to. So we have to do the inverse of that. So we're going to subtract whatever that number is, because that gives us 0 and we want x to be by itself. Whatever we do to one side, we have to do to the other. We're left with x on the left. 16 minus 5 is 11. Then we would throw it back in here. 11 plus 5 equals 16. 16 equals 16. It checks out. Okay? Let's see. How about 13 equals 9 plus r? Now don't get all confused here. It's still being added to the r. So we have to do the inverse of addition, which is subtraction. So we have to subtract the 9 here and from the left side. When I say left and right, I'm talking about the sides of the equal sign, right? And I put it right under where I'm taking away from. So that becomes 0, and all that's left on the right is r. 13 minus 9 is 4. So I would write this back in. 13 equals 9 plus 4. Yes. It checks. There you go. All right. I know we're running a bit long here, but I do want to give you some to practice on your own real quick. So let's do 5, 6, 7, and 8. Go ahead and try n minus 8 equals 6. You have to show all your work. I don't want to hear I did it in my head, because I have told you that you absolutely positively have to show your work. These problems are going to get harder and harder, and you need to be able to do these steps. So you absolutely positively have to show your work. Oh my goodness, you guys. That was supposed to be a minus k minus 13. Alright, so give these a go. Pause your video and try them. We got to add 8 to both sides. That leaves n and 14. So I would say 14 minus 8 equals 6. That would check out. So there's my answer. I have to subtract from both sides. So that leaves me with 8 equals a. So 8 plus 9 equals 17. That works. There we have it. Remember, it doesn't matter if it's being added, it's being added. So you still have to subtract it. That leaves us with z and 2. So 14 plus 2 equals 16. Alright, make sure you've paused your video and are trying these. If it's being subtracted, we have to add it. That becomes 0. So then I would say 7 equals 20 minus 13. And it checks out. So there's my answer. Okay, hope you have a fantastic Tuesday.